All right, today we are diving into a concept from abstract algebra that is honestly just so cool in its simplicity. We're talking about cyclic groups. Let's get right into it.
So let me ask you a question to get us started. Do you think it's possible to build an entire complex system from just one single piece? I mean, it sounds kind of impossible, right? Well, in the world of math, the answer is a huge yes. And that's the whole idea behind a cyclic group.
Okay, so this is what we're starting with, the official formal definition right out of a textbook. Now, I know, it looks a little intimidating with all the symbols, but trust me, we're going to break this down piece by piece, and by the end of this, it's all going to make perfect sense.
So first things first, let's look at the official blueprint. What on earth is a cyclic group anyway?
In plain English, a cyclic group is a group where every single thing inside it, every element, can be made from just one special starting piece. All you have to do is take that one piece and combine it with itself over and over again. It's like building an entire Lego castle using only one type of brick.
And that one special element? Oh, it has a name, and it is the absolute star of this show. It's the most important part of this whole puzzle. We call it the generator. This word is everything. The generator. Think of it as the powerhouse, the source code, the one single item that does all the work to create everything else in the entire group.
So, what does this generator actually do? Well, let's just call it A. Every other element you can possibly find in the group is just A raised to some integer power n. You can think of A as the founding member of a club that ends up creating every single other member.
Okay, I know this all sounds a little abstract, so let's make it real. Let's actually watch the generator build a group, step by step.
It's really just a simple, repetitive process. You start with your generator, A, then you combine A with itself, and boom, you get the next element, A squared. You do it again, you get A cubed. You just keep going like this, creating this whole chain of new elements from that one single starting point.
But now, look at this. This is straight from our source material. The power that A is raised to can be any integer. That's huge. It means we don't just move forward with positive powers, we can also go backward with negative powers, which basically just means using the inverse. So you get a whole other set of elements that way.
And what about the integer 0? Well, a to the power of 0 gives you something really special. E, which is called the identity element. This is basically the do-nothing element in the group, and because of this rule, we know for a fact that every single cyclic group has one.
Okay, so you've got the concept down. Now let's quickly look at the official notation so you'll know it when you see it out there in the math world.
It's actually really simple. If you have a group, let's call it G, and it's generated by the element A, you just write it like this. G equals A inside these angle brackets.
So yeah, when you see that, don't let it throw you. It's just a super compact shorthand way of saying exactly what we've been talking about. The entire group G can be built from scratch using only the generator, A. That's it.
Now, before we wrap up, there are two quick but really important details you got to know. First, when you're generating these elements, A squared, A cubed, and so on, you might actually start repeating elements you've already made. And that's okay. In fact, that's what happens in finite groups. And second, and this is a cool twist, a group can have more than one generator. It's totally possible for some other element to also have the power to create the whole group.
So what's the big takeaway from all this? It's that the real beauty of a cyclic group is just how simple it is at its core. You have one single element, the generator, and it holds the complete DNA for the entire structure. Everything comes from that one source. And that leaves us with a really fascinating question to think about. If a group can have more than one generator, what is it that gives an element that special power? What actually makes a generator a generator? Something to chew on. Thanks for joining me for this explainer.